Okay, so I collected some data with the coffee filter falling, and we're going to try to find our portion of terminal velocity. So let's start here. Okay, so if we look at that, we see this one's way off this portion, so it's not at terminal velocity at this point. We see it still has some curvature here. So we're going to want to select somewhere further up on the graphs. If we notice, it's still kind of, this linear fit is still angled from up here. So we're going to adjust it up this way. Now that looks a lot closer. If we notice here, we can still see the curvature. You can still see the curvature here. So it shows that it's still accelerating at this point. So it's not terminal velocity until up here on the graph. So we can record that value as our terminal velocity is our slope, 1.128 meters per second. So that would be a particular trial for one coffee filter. So we're going to repeat this 5 trials for 1 filter, 5 trials for 2, 5 trials for 3, 4, and 5 filters. Okay? And we will plot on Excel our average terminal velocity versus our mass. And we will plot our average terminal velocity squared and our mass. And then our average terminal velocity cubed and our mass. And making sure that you include 0, 0 in your data set on each graph, we will use our R-squared value from Excel to tell us which is the most linear. The most linear graph will be the best model based on your data, okay? So R-squared, again, that's the coefficient of determination. The closer your R-squared is to 1, the more linear the graph is. So that's going to be our measure to determine which of these models best fits our data, okay? So this is going to be an experimentation on finding a model that works for the force of air resistance. Now this constant K we can calculate. So in each case, our slope is equal to rise over run, which is our terminal velocity to whatever power, 1, 2, or 3, divided by m. Because we know, and since we know that v over m equals g over k, solving this equation, we can use our value of our slope from Excel, plug that in, set that equal to g over k, and solve for k. So you know your slope, you know g, and then you solve for k one time using your slope, as opposed to solving it for each individual trial separately. Okay, so this is a method that we have been using a lot, and we will continue to use this, using the slope to do calculations. Okay, so you will solve for k, making sure to use the correct units based on whatever power you have here. And that's, again, determined by which graph you chose as being your best model to fit your data. Okay, so that is the air resistance lab for physics. Thanks.